department for QuickBooks Live. So my focus was, I believe we have an issue with customer cancellation. So that's the basis of where I'm going with this project. So I'm just going to get started here. So this is a multi-class classification problem that I use to determine customer types based on the following criteria: escalation ticket counts, call prep time, scheduled appointment time, unscheduled appointment time, and the total number of accounts reconciled by our bookkeepers. So the problem to solve is, in my experience, I believe we have an issue with customer cancellations. My goal is to explore the data and try to understand customer behavior. My assumption is customers are canceling due to the extended cleanup start times from the time they purchase. So to prove this hypothesis, I will need to show a date difference. I need to show that it decreases, and at the same time, tenure should increase. So my limitation is I don't have access to 2022 data. So these are the number of files that I used to create this capstone. I did create some videos to talk more about these files due to our time constraint. And these videos also show how to deploy something like this to the web. If you're interested, there's a 4-minute short as well as a more extended version. So if time allows, maybe we could watch the 4-minute. If not, this is out on the web, so you're welcome to look at it. The best thing you could do to pull this up is pull it up in incognito, and it'll load a lot quicker for you. So I'm moving on to my data. And this is my data. As you can see, there's large variances in the data that I have. And again, I had limited data access, so I couldn't retrieve more data. So this is what I had to work with. And as you can see here on this, between the 75% and the max rows here, there's huge variances in the data. So moving on to the relationships between the data, the basis of my predictor is tenure. So with tenure, non-appointment, appointment, and call prep are the most impactful as it relates to tenure. However, the relationships among these features, the variables are not linear. So I also did the correlation map, which shows in blue, these relationships are not very close, but these in the center, the red, these are the features that I focused on my features. So we got reconciled accounts, non-appointment call interactions, appointment call interactions, call prep, and also that date difference between the purchase and the customer start date. So I want to focus also on the missing data. I did a crosstab query to show the years that I have are 2020, 2021, and 2022. None of these years have a complete gathering of data for every single month. So there is a bit of an incomplete collection of data. So I just wanted to put that out there so you kind of have that in the back of your mind when we're looking at the purchase and cancellation activity in the next section. So in this section, I showed there we have a lot of purchases here in February and March. A lot of purchases. Great year. And this was for 2021. So that's, of course, that's the pink. That's why it kind of goes over here, 2021. But right after that, we have a lot of cancellations. So it's like, oh, we got a great purchase, but now we got a lot of cancellations. So what's the problem? So this is the reason I started this project. So the graph, I kind of was thinking it was a difference between the cleanup. We're just starting too long to start cleaning up these books. Maybe that's what it is. So this graph kind of proves that. Here it shows if we started cleaning up the books within 30 days or so, we had a lot more customers stay for a longer period of time. But the longer we took to start cleaning up their books, there was a stagnant here in their tenure. So they didn't stay with us very long. So that kind of proved my point there. But there's still other reasons why customers cancel. So here's my test sample. So in my test sample, I have all those features that were pointed out in the heat map. And I have my tenure field as well here. So here's my tenure column. So I wanted to find a way to kind of categorize the type of customers, like why are they canceling? So once I extracted my key variables, I decided to take the average of every single one of these columns and just eyeball it and see if I could see a difference in the performance. And so I also decided to take the tenure variable and break it up into 5 groups. And I did that using bins. So these are the bins that I started with. So now I've got my data broken up into bins, and I've got the average of this data. The average of each bin, I have 5 bins. So now just eyeballing it, I was able to see what's happening here. So when you click high maintenance, there's a graph here for every single one of these types. And I can see here just for the reconciled accounts, high maintenance customers have the highest reconciled accounts. And as you can see here, if you go over to reconciled accounts, they have an average of 69.56. That's the highest of any other. If you click on dissatisfied, the graph should change. Does it change for me? Give it a minute. Oh, it might not change for me. Unfortunately, maybe it's because I'm in incognito. I'm so sorry, guys, you couldn't see that. But if you see it in a regular browsing, you could see the graph change. But the graph was supposed to change for you to see that the dissatisfied customers, they also have their own behavior here. So each one of these, oh, it changed for me. Look at that. Sorry for the delay. Okay, so on the dissatisfied, you can see here for dissatisfied customers, they had the highest number of escalation tickets. And you can kind of hover over it a little bit. And they had maybe one ticket, for this one, but and the potential loyalists, they have the highest number of doc management. And that ties in with this here. So yeah, so if you, as you click one, you can see the customer behavior. Okay, so I'm going to move on for the sake of time. So again, I was kind of looking at every single type to see if my classes are even balanced. Here I found out that the satisfied customers, they're underrepresented. So I'm knowing right off the bat when I make my predictions, I'm probably not going to do very well on the satisfied customers because they're underrepresented, but all the other classes appear to be balanced. So moving on.
Minutes.
Yes. Oh, 2 minutes. Okay. So
Yep.
on the model performance, I evaluate using my logistic regression model using the score method. I took the difference of my test and train accuracy, and the difference was very small. I also used K-folds to graph the mean absolute error against the folds. The model indicated test and train, and my E range was very small, so this meant the model was not overfit. So I did improve the score using the random forest classifier. So if you look here, I did include all that code so that you could see um, what that looked like as far as the code is concerned. Also, I added the graph to show why it was not overfit. So you can see that comparison there. And there's the score. So scrolling down, I was able to also apply dimension reduction and improve my accuracy score using PCA. I plotted the PCA performance below and to show the performance peaks when in neighbors is set to 2. So as you can see, this is why I use 2. So that's the model. And then I also added the feature importance. So I wasn't really surprised here because we saw this in the heat map. So it just kind of reiterated those key variables as the most important variables to consider if a customer is going to cancel or not. So I'm just going to scroll down on my predictions. If you click on each tab, it's going to show you what the predictions were. High maintenance, I 100% predicted accurately. On dissatisfied, there was a couple that were off. Loyalists, there was a few that was off there as well. Potential loyalists, there was a couple off there as well. So this is sort of a big overview of what it looked like, just looking at all the data, the actual versus the prediction. And lastly, I took the rock curve AUC score because this is a multi-class classification. So just going to satisfied, I know this was underrepresented, and sure enough, the score was off by 0.28% as opposed to all the other classes. And overall, the accuracy score was 70% for all the classes. So in conclusion, I was able to determine there are several factors that affect customer cancellations. The most prominent features, non-appointment calls, and prep time. So I was able to create customer types based on different features. However, the imbalance of my class affected my micro average accuracy score of my multi-classification model. In the future, I like to gather more data under satisfied classification to balance my classes and improve the model accuracy. So that completes my presentation.
Well, awesome. Coupled before we get just the interactivity and the way that you found like a website to render and allow
Mhm.
for interactivity when like GitHub doesn't.
Mhm.
Great, very resourceful.
Yeah, and it's here if anyone wants to learn how to do that. This resource link right here is the person that I learned it from, but these videos show how I actually did it. So that's out there, if anyone's interested.
That's
Can
great.
you drop it in our classroom
Sure,
chat in Slack so everybody has it?
sure, absolutely.
Awesome. And but then onto the model. Do you see a
Oh,
world where you guys?
I'm
Sorry.
gonna go back. Sorry.
No, of course, of course.
Let me go back. I'm a little nervous, so sorry about that.
Nothing to be
No
nervous
need
about.
to be.
You did a great job.
No need, no need.
The question was, you have this model that now kind of predicts customer value or customer
Mhm.
sentiment or customer attrition. Do you see this being used by your firm at all? Do you see it being implemented?
I don't know. I'm going to share this with my manager. To be honest with you, I'm actually just an escalation agent. This is not my field. Data science is not what we do. So, I mean, as an agent, but it's something that they want to know. Why are we having so many cancellations? So,
Yeah.
with this
Well,
research, I'm hoping to share
I
maybe a little
mean,
insight.
I appreciate you saying this is not what you do, but you just did it.
I did.
You did it.
I did do it.
And so, I mean, for everyone, by the power vested in me, you are all data scientists. Like
Me.
you guys should like think about it. Thank you, Marlena. Sorry, any other questions for Marlena before she ends? Okay.